Welcome to Fire Engineering Training Minutes. I'm Sean Gray, out here with Deputy Chief PJ Norwood, and today we're going to be talking about small-scale fire behavior training. Here behind us, we have the box that we have all the plans and building plans that you'll be able to get, and PJ is going to walk you through the whole entire process of setup, how to burn the box, and how to teach your firefighters fire behavior.
So welcome. So this is an excellent fire behavior training prop that can be used to show the basics of fire behavior, but you can also incorporate your tactics into. Today we're going to show you the basics of fire behavior and how we burn this box and move the fire through this box, and we demonstrate multiple facets of fire behavior. I have my helpers here from Cobb County, Georgia. They're going to come in, they're going to light the fire in this box, and while they do that, I'm going to show you what we're using for materials. So we're starting off with some dry straw and some pine strips. This dry straw and pine strips is located only in the lower left compartment of this box. That's the only compartment that we're putting fuel into, because that's where the fire behavior is going to begin. As this fire progresses and burns, the box itself becomes the fuel. That's why there is no additional fuel needed in compartment 3 or compartment 2, which is the bottom right and the top right compartment. So again, the only compartments that fuel's going into is the bottom left. What we want to explain to our students, as this fire is lit and begins to grow, you start looking at the smoke, start looking at the color of the smoke, start looking at the velocity and the density of the smoke. And you'll see the color of the smoke here is light in color, almost a white or a gray. You want to explain to your students that this is more of a legacy fuel. It's your hay, your straw, your pine. Once this compartment gets going, we're going to change that fire behavior and change how the fire reacts by controlling the ventilation openings, by opening and closing those ports to decrease the amount of oxygen or increase the amount of oxygen into each compartment. We're also going to add some polystyrene materials to show the difference in the smoke. So now we can then look at modern fuel package that we're actually seeing in today's homes. The beginning part of this drill, it will at times seem like it takes a long time for the box to get going. But once the box heats up, the OSMB starts burning and starts off-gassing, we'll rapidly transition to an excellent fire behavior drill. So my two partners here from Cobb County, at this point, they're watching the fire behavior, they're taking a look at how the fire progresses, and we're giving it plenty of air. We're allowing the materials, the legacy materials that are in there to get going, to start burning, and start preheating that compartment so we can get the OSMB burning and off-gassing. So now that we have that compartment going a little bit, we're going to go ahead and introduce some polystyrene materials so we can see the difference in the smoke. So they're going to go throw these styrofoam cups into that compartment, and we'll start seeing a change of the smoke. The smoke will start getting a little denser and a little darker, and you'll start seeing a little bit more volume. They'll also begin to shut down that compartment and decrease the amount of air, decrease the amount of available air in that compartment to burn. As they do that, there's some things you should start to look for. You can see a change in the color of smoke. You can see the neutral plane. You can explain to them the difference between what the neutral plane actually is and bidirectional flow. Show that the smoke, the heat, and gases are escaping out the top of the box, and the fresh air is coming in the lower part of the box. You could begin discussing conduction, convection, and radiant heat, and how your gear actually works when you're in these environments, when you're fighting structural fires. You'd see my partners at this point, they're just opening and closing that opening. They're controlling the openings just to progress the fire a little bit more, and by adding more air, it's going to increase the speed of that fire and how that fire will develop. You'd see now they provided a lot of air. We started seeing that fire come out of that compartment. As he shut that down, you can clearly see a neutral plane. You can see the bidirectional flow, and you'll begin to start seeing that smoke almost puff and get turbulent as it comes out of that compartment, because that fire that's burning is just looking for more air. It's looking for air, so it's trying to pull all the available air into that compartment. This is the same as we have in our house fires. Now you can see the smoke is a little bit darker and denser. You can clearly see a neutral plane and some bidirectional flow. And we started to have a little bit of fire coming out of that compartment. Now as if he opens up that compartment just a crack at this point, you'll see that smoke start to push, and you'll see the bidirectional flow and that air being drawn into that compartment. As he opens up that compartment more, we're providing more air, so we're gonna have a greater fire. What we have to remember is in our fire tactics, whatever we're doing on the building is creating a hole, which is ventilation. Whether we're fire attack, we're forcing entry, we're search, or whether a door fails or a window fails, that's providing ventilation. In the past, our ventilation was, we thought of just breaking a window or just cutting a hole in the roof. And what happened here is he closed down that compartment. He limited the oxygen into that compartment and actually snuffed the fire out. It's the same thing we like to talk about during our fire prevention and education is when there's an oven fire. We tell our occupants what? Shut the oven door and the fire will go out. We just did the same thing here in a wood structure. We just controlled the amount of air and we actually choked that fire out. So just by controlling the openings affects the fire behavior. So at this point in the drill, you want to let this compartment get going again. You want to really start heating that OS&B up. And shortly we're going to open up compartment 3 and we're going to remove the door that goes from 4, which is lower right, to 3 to the lower right. So you see we opened up 3, but we don't have a lot of smoke pushing out of there. But now as he opens up the door between the lower right and lower left, you're going to see a change in the fire behavior. You're going to see this lower left become an outlet only. When we say outlet, that's just where the fire is exhausting out of that compartment. You don't see a lot of air, you don't see a lot of bidirectional flow or a neutral plane. If you take a look at compartment 3, that compartment you have some bidirectional flow. You have an exhaust port, but also in the lower part of that compartment, you see the intake or the inlet of the fresh air. That's traveling across to the lower left compartment to feed that fire. If we were to shut down compartment 3 completely and lower left, we could again choke this fire out just by limiting the amount of air. And as he closes this compartment and we shut down lower left and he opens that up just a little bit, you're going to start seeing that smoke puff and you see it really starving and looking for that air source. So we're going to open up lower left a little bit more. Give it the air that it needs. As you can see, very little air allowed that compartment to almost flash over, like a ventilation-induced flashover. So we're going to open up lower left and get that compartment going again. And we can open up 3. Now close down lower left. Strictly by controlling where the fire is getting its air source from, we can control where the fire goes to. So we can control our buildings by playing with the openings. You see over here in the lower left, he's just opening and closing that compartment, and we're clearly showing you a neutral plane there, some bidirectional flow. And you're going to see those gases, or the smoke, the unburned products of combustion, that fuel, start lighting off. Now remember, there's no fuel in lower right. That is strictly the smoke. That's the gases that's beginning to flame over and ignite in the lower right-hand compartment. You'd see lower left is still burning. We have plenty of heat in that compartment. And now over to the right, we're getting the heat, the fuel, and the oxygen that we need to have ignition. You'll also notice if you look up towards the top or the ridge line of this house, you start having increased smoke production at multiple levels or multiple floors to this house. The same way you would with a standard 2-story wood frame private dwelling. You're going to start having smoke migrate through the entire house along with the heat and decreasing the amount of oxygen on all levels of the house. When you do this drill, it's always good to have a water sprayer from a garden hose or a 2.5 can pressurized water extinguisher available, because you want this drill to go on as long as you can. So if you keep wetting the exterior of the box, you can keep that compartment and that box intact as much as you can. And what you see now, the partners, they're just controlling the openings, allowing air in or allowing air out. And we saw a little ventilation-induced flash over there. See compartment 3, the smoke is a lot darker, it's a lot denser. So we're creating a lot more heat within this box. So now he's going to close up 3, and we're going to start moving up to the 2nd floor, and we're going to open up number 2. Now see, as he opens that, we have some decent smoke, and we have that bidirectional flow, and you're going to see the building start really pushing and pulling and really looking for more oxygen. And he's gonna reach in and he's gonna remove the hole in the floor that's simulating a door, and you're gonna see things change a little bit. What we're gonna do is we're gonna actually draw the fire up into that compartment, because what's the fire always gonna do? It's gonna travel to the source of oxygen. And you just clearly saw that we just had a little phenomena there where it grabbed the oxygen and it flashed a little bit. And standing here, you can actually almost feel a little pressure wave. So we can start showing the differences or talking differences between flashover and backdraft. As we close the lower left compartment, we'll start seeing that we have fire that has moved all the way up into the top right. Here's your water sprayer if you want it for the outside of that compartment if necessary. So now we have good fire going in the entire bottom left compartment that's migrated to the bottom right. And now you're starting to see an increase of heat. You're starting to see that smoke become a little bit more turbulent, a little bit darker. We still can clearly see a neutral plane there. We have that bidirectional flow. If he opens up number 2 just a crack at this point, which is the bottom left, we're gonna open up bottom left, you're gonna see a change in that opening. You're gonna see the smoke increase of speed. So now watch as he closes the lower left. We'll see the smoke is still present, but the smoke slows because it doesn't have an oxygen source below that level. As he opens up the bottom left, you're gonna see that smoke increase in pressure, increase in velocity, and it's also increasing in heat. So that would be similar to a 2-story house if the window lets go, or you perform horizontal ventilation on the floor above a fire. As we keep playing with these openings, those gases will ignite. The more air, the hotter the fire gets. For a long time, we were always taught that ventilation equals cooling. Ventilation doesn't equal cooling, water equals cooling. So ventilation will increase your heat release rates and it will increase your opportunity or chances of flashover or backdraft without water application. So you see the more air or less air that they provide to this box really changes the fire behavior. So as you see, as we supply more air into this environment, we're increasing the temperatures, we're increasing the products of unburned combustion, which is more fuel, and the fire is lighting off in the smoke. As you'll see, as he opens up bottom left again, we're gonna see the smoke in the top right begin to light off. And that's just because we're increasing the heat. Even though we're ventilating, we're increasing the heat, and that smoke will begin lighting off. As you see, we're providing a lot of air below the fire and also above the fire. So it's getting really turbulent, it's getting very dense, and you can see that upper right doesn't have a neutral plane. That's strictly an outlet. Your inlet is your bottom left. You can see the smoke and the heat getting drawn right in there. Now we can shut those down. We can cool the outside of the box with the water. What I want to do is I want to simulate roof operations. So in the small scale fire behavior prop, we also want to show the positive and negative effects of roof ventilation. We have 2 slide trays or 2 slide trays built into this prop. We have one at the roof or at the peak, so now we can open that up and it shows what performing roof ventilation or cutting the hole in the roof actually does. But the important note to our students is that just cutting the hole in the roof isn't enough. We always need to push down and break down the sheetrock. And so we have another slide tray that we're going to open now to simulate breaking open the sheetrock. And as we do that, you can see the velocity and density of the smoke increase. And without water application, we will have fire that comes out of this roof. This is an important point to show to our students that vertical ventilation is positive, but it's only positive when we have a coordinated fire ground and we utilize that with fire attack at the same time. The speed of this drill depends on the speed of materials and how quickly the box burns. We're just going to open up a couple more compartments and show you. We've lost the integrity of the box. We have a hole in the back of the box. We may not be able to show you too much more fire behavior because we're just adding too much air, but we're going to go ahead and open up a couple compartments and you guys can go ahead and play with those openings, see if we can get some flashovers to occur. All right, close them all up. What I want you to do is open up all 4 at the same time. So as you can see, at this point, we've lost the integrity of the box. We have some collapse of the second floor. And you can see the more holes that we put in the building, the more air that we supply, the bigger the fire grows. the increase of the heat. So again, this drill or this training can be utilized to show fire behavior. You can talk about fire attack, you can talk about search and rescue, you can talk about vent, enter, isolate, search, as well as horizontal and vertical ventilation.
All right, so we just had a good demonstration of fire behavior, and want to thank you guys for showing up today. PJ Norwood, Sean Gray, Fire Engineering Training Minutes.